Today I'm going to go over parametric modeling and show you how it's done, and then you will be creating cams based on some parametric modeling guidelines. The definition of parametric modeling is it is the 3D modeling where geometry is created with association to other geometry. But what does that mean? It means that we are going to take certain geometry and we're going to relate it to others. And we use that through the use of parameters. And so we're going to create relationships between certain parts of the geometry of our cams. For example, maybe a radius is related to the length of another side. We will need to know and have an understanding of a nominal dimension. And a nominal dimension is one where it's given a name which may or may not relate to the actual measurement. The very famous example, or the most common example, is a 2x4. If you go to a store and you get a 2x4, it is not actually 2 inches by 4 inches. It is actually 1.5 inches by 3.5 inches. And the reason it's called a 2x4 is before it was planed down and made smoother and more of a consistent size, it was approximately 2 inches by 4 inches. If you go into older buildings, sometimes those 2x4s actually are 2 inches by 4 inches. But now if you go into a hardware store, you're going to find that most of the actual 2x4s are 1.5 inches by 3.5 inches. But we still call it a 2x4. It's a little easier, and it still does relate, although it is not the actual measurement. How do we know what parametric modeling is? Now we're going to see it in action. And this is all part of 4.1.2, Cams Make the World Go Round. And on here, there are some dimension drawings. And these show the dimensions of or really the relationships between the different parts of the geometry. And so for this assignment, I'm going to have you create 3 of these. And in this video, I'm going to go over 2 of them. One of them is going to be the pear cam, and then the other one I'm going to do is going to be the hexagon cam, or hex cam. So I'm going to go over these later on in a more in-depth video. I may show how to do a snail cam, but that's going to be kind of the advanced thing. So for this assignment, I'm going to ask that you actually create 3 of these cams in Onshape. So we're going to switch over here. Oops, I already did one. And so I'm going to go ahead and delete this one because we're going to start all over. So now I have, let's see, a new Part Studio. And the first thing I'm going to do before I get into actually drawing anything is I'm going to create my first parameter. And here in Onshape, we can actually do that using a variable. And so in math, we so often use it as x as our variable. And so that is the icon that we're going to start with. And for this, I'm going to label it, and it's going to be something that I actually have to type in fairly frequently. And so I'm going to make it pretty short. And what I'm going to do is have a lowercase d, and that's going to be my dimension, my nominal dimension. And in this case, I'm going to put in 2 inches, and that is there just to give me a number. I can always change this later on, and I'll be showing you how to change that later in the video. Okay, so now I have a parameter that is the lowercase d. Now I need to draw, and so I'm going to go into and create a sketch on my front plane. And I'm going to have to go back and forth between my drawings and my model. And so for this one, I'm going to start with the pear cam right here. I'm going to look and see. So I've got kind of this rounded shape. It looks like most of a circle. I've got another part that, I could think of another circle being in there. And then there's kind of straight lines in between them that look pretty tangent to that. And so I'm going to draw that fairly quickly. A good place to start is to actually create a circle, and that's going to be right here is going to be the center of that through hole. And in this case, we're all going to use the same one, and so I'm going to use a diameter of 3/8 of an inch. Okay, so all of those are going to be 3/8. My axle will be 3/8 of an inch right there. Then what I'm going to do is I'm going to make a big circle for that kind of big bottom part. And then I'm going to make another circle that's right above it. Okay? And then from there, I also could see that there were some lines. And one little trick is if you want a tangent line, you can draw them extra big like that. And then what I'm going to do is I'm going to use my parameters here, my constraints, and I'm going to make this line tangent to this circle, this line tangent to this circle, this line tangent, this line tangent. And now we've got it pretty close. If I want to, I can actually take my trim tool and get rid of some of those extra lines. I can actually wait to do that later on as well. I'm seeing there's a little bit of a gap, and so in this case I might even extend to here, and again I might extend this line to there. And so now it's a complete shape. It's all good. Time to put in some dimensions. Now the first thing I'm going to do, I'm going to trim, go back to trim, and I'm going to trim away these, and that just makes it so that my dimensions will actually match and a little less math going on. So here we go. This first one right here has a radius of 2.39, but we actually want, according to our drawing, a radius that is half of our diameter, our nominal diameter. So what we can actually do is say lowercase d, and then my parameter shows up, and so $d/2, that's my mathematical formula, and I hit enter and it all resizes. Okay, and that gives me the actual dimension. 2 divided by 2 is 1, so I have a radius of 1 there. The next one has a radius of d divided by 8, and so I can go back here, and with this arc right here, got a radius, I can take by $d divided by 8, and now that's going to be approximately the right size. And then the last thing I need to do is, well, second to last, I'm going to put this dimension, so from my center to my center, I'm going to dimension that. Center to center. And I've got to see that is d divided by 2 yet again. So I'm going to go here, $d/2, and pretty close. We're still not fully constrained, and that is because this right here is not necessarily straight up from the other one, and so I'm just going to make this vertical from my center. Now it is aligned and fully correct. From there, I can actually then extrude this shape right here, and I'm just going to make this again 3/8 of an inch right there, and there is my pear cam. If I want to, I can actually go in and edit my variable, so I can change this to maybe a nominal dimension of 3, and once I change that, that's going to make it larger. If I go back into the sketch, you can see all of my dimensions have scaled. That's kind of the great part about parametric modeling. You can create one model and then have it ready and make one change, and the whole thing changes quite a bit. Now this is actually going to be more difficult than the hex cam. So I'm going to go and create a new part studio. And I'm going to sketch again, change my view. This time I'm going to find my shape tool. And it doesn't matter because we're not going to actually dimension based on the circle. So I'll just do inscribed. So it goes center. It already is a hexagon, so I don't need to change that. I just need to make sure it stays a hexagon. So I click to the center, click somewhere to the outside, and then clicked one more time to confirm it is 6 sizes. From here, all I need to do is go from the center here, and this one says, oh, I've got a problem. I actually don't have my parameter yet, so I can just change that, keep that where it is, go back into, go out of sketch mode, and add in that parameter. Again, I'm going to change it again just to D. I'm going to have my default be 2 inches just to start, and then go back in and create that sketch, create that polygon from the center, on the way out, make sure it's 6 sides. There we go. Oh, probably want to have this line be horizontal. There we go. And then put in my dimension from here to here, right there. D divided by 2 according to my drawing. And there we go. That is it. All I need to do now, make that circle for my center. Okay, 0.375, which is 3/8 of an inch. Extrude right here, 3/8 of an inch. And there we go. I can change this number right here and be all good. Now I said I was going to do 3 of them, or 2 of them, but I think I have a little bit of time. So I'm going to actually do the third one. The third one's fairly quick. This is an eccentric cam. All I need to remember is that the through hole is 1/4 of the diameter from the center, and then the diameter of that circle is the nominal dimension. So again, sketch, front plane, change my view, draw a circle, draw my other circle, make sure it is vertical from the center. Always forget this though, which is got to put in my parameters. D2, all good. Got my parameter in there. Go back into my sketch, dimension, oh, I gotta make sure my parameter is up above my sketch. That'll work now. Divide by 4. And of course, the last thing, 0.375. There we go, all done. Extrude, let's take a look. 0.375, there we go. That is it. Now if you want to have an extra challenge, go ahead and try to do all 6 of them, but for the assignment I'll be asking for 3 of them. Create those models and we will continue again on Monday.